The magnetic material, so in terms of behaving within the magnetic field, there are different types of materials, their behavior in the magnetic field. So magnetic material, what are materials? Material that are attracted by the magnet, or it can be magnetized or behave like a magnet, such as iron, steel, cobalt, nickel, and few of more examples are there, but these are enough. So example, if we have a permanent magnet. So if there's a permanent magnet and we bring a piece of iron, we bring a piece of steel, cobalt, or nickel. So what will we will observe? We'll observe that, so originally the domains are not aligned for any of them. The domains are random originally. So domains for iron, domains for steel, domains for cobalt, they're not aligned. But when we bring inside the magnetic field, their domains are aligned. As the domains are aligned, we call that as a magnetic material. But some of the material, like example, if this was iron, steel, nickel, or cobalt, this will happen. But what if we have another material, like example, we have copper, aluminium, wood, and any other like plastic. So for them also, the domains are not aligned, the domains are not arranged. So example, if this is aluminium or copper is there, Cu, I'm writing the symbol only, or wood is there, rubber, plastic. So domains are not aligned. And when we bring them closer to the magnet, the domains still remain random. So what we call this material, these are known as non-magnetic, and the material in which the domains align, we call them as magnetic. And magnetic materials are also known as ferrous material. Ferrous is from the chemical name of iron, ferrum, because it was believed that only iron is a magnetic material. Iron was a magnetic material. It was a belief only, but later they found that it's not only iron. There are many other materials which can be magnetic, but because of old name of iron, the thinking was that they think only iron is behaving like a magnet, so they called them as a ferrous material. And non-magnetic are also known as non-ferrous material. But this is the old name which was given to non-magnetic material. Nowadays we call magnetic and non-magnetic rather, but they can use this term, they can mention ferrous or non-ferrous. And these magnetic material can be divided into further two classes. Ferrous material are further divided into two main classes. One is called soft. The softness is not in terms of the texture, the softness or hardness is in terms of the behavior. Like example, when we say a soft magnetic material, it means when we remove them out of the magnetic field, the domains again it turn into random. And but some of the material, when we remove them out of the magnetic field, their domains still remain aligned, so we call them as hard magnetic material or hard ferrous material. So hardness and softness is not in terms of the texture, it is in terms of a magnetic field. So soft magnetic material, they are temporary magnets, they behave like a magnet only when there is a magnetic field. Once the magnetic field is removed, they don't behave like a magnet. An example of the soft magnetic materials such as iron. An example of hard magnetic materials such as steel. So steel is a hard magnetic material, means once its domains are aligned, it will behave like a magnet. For iron, it is a soft magnetic material. Once the domains are um, like the material is removed from the magnetic field, it will not behave like a magnet until unless there is another magnetic field. Is it clear the basic difference between the ferrous and non-ferrous material? And then ferrous materials can be classified as a soft magnetic as well as hard magnetic. So the magnetic material, they are attracted towards the magnet or they remain magnetized. Non-magnetic material are not attracted towards the magnet like brass, copper, zinc, tin, aluminium. Because the reason why I repeat this example is because students think that if it's a metal, it should be a magnet. It's not the case. Material, all the metals are not a magnetic material. They don't behave like a magnet. And if we are magnetized materials which act as a magnet or have all the magnetic properties are known as magnetized material. If you want to make a magnet, there are different ways to make a magnet. Number one, electrical method. Because whenever the current is passing through a wire, the material will behave like a magnet because the current means the movement of the charges or particle. Like if you have a cell, maybe you have performed this experiment in your science fest in maybe class 5 or 6. So this is a cell which is a positive terminal and negative terminal. Very common experiment student used to perform like grade 5 or 6, that they take an iron nail and they wrap the wire around it from the battery. They wrap the wire around it. You can also perform this at home. This is a simple experiment. So when we connect a cell or a battery which provide the charges, the current which start to flow, and that current will flow through the wire. So whenever the current is moving or flowing through a wire, the current is always produced, because current means movement of the charges. So current produces a magnetic field. So when there is a current, what as a result, the current, what it do? It will produce magnetic field. And as a result, when the current produces a magnetic field, this material, and this material should be a magnetic material. If it is made up of copper, aluminum, it won't work. If this is made up of iron or steel, it will work. So as a result, what happened? This material will behave like a magnet. One side will be north pole and one side will be south, and it will attract the other magnetic material towards it. So we call this technique as a method of magnetization by electrical method. This is known as the electrical method of magnetizing a material. Is it clear how we magnetize a material by electrical method? Just wrap the wire around the object and pass the current. When there is a current, there is a magnetic field. And as a result of this magnetic field, the material will behave like a magnet. So you can perform this simple experiment at home as well. Take iron or steel nail, not other, like you, it should be iron or steel nail, and wrap the wire around and connect with a normal like 1.5 or 3 volt. And this iron or steel nail will attract when you bring closer to other material, like example paper clips or any iron object or steel object. They will be attracted towards it because it is producing a magnetic field and it magnetizes the material. So the electrical method, we pass a steel bar is placed inside a solenoid. What is the meaning of solenoid? Solenoid means a coiled wire. So steel bar is placed in a solenoid through which direct current is passing. What is the meaning of direct current? Means the current which move in only one direction. The current is not otherwise, because if the direction of the current changes, the direction of the magnetic field will also change. So cell or batteries provide a DC or a direct current. So a strong magnetic field is produced, and when we view, the material will behave like a magnet. Like here you can see this is a solenoid. A, a wire is there which is wrapped around many times. This wire is called a solenoid. Then what we do, we connect a battery here, like positive and negative terminal connected to the battery. So the current start to flow, like this is the direction of the current. The current start to flow through this, and we place an object inside. This is hollow here, like there's a space, so we put an object inside. That object will behave like a magnet, so we call this as electrical method. The second method is known as stroking. Stroking means like hitting or rubbing basically with a magnet. The material will behave like a magnet. You can also use this technique. So what we do, like example, this material originally it was not a magnet. There's a steel bar. Originally it was not a magnet. Now what we do, we rub this many times. Like we put this permanent magnet or rub with a magnet, permanent magnet many times. As a result, when we rub, because originally the domains are random. In the beginning, the domains in the steel are random. But when we rub it continuously in one way or one direction, as a result, what happens? The domains will be aligned. And when the domains will be aligned, it means this steel bar will behave like a magnet. And what will be the poles induced? Always the opposite pole will induce. Like example, as we rub, so north pole will leave here. So north pole of a magnet will leave here. So what pole will be induced? South, and opposite will be north. And you can see here, it can also be like double touch or divided touch. So by rubbing with two different magnets. So we rub south pole. When so south pole is leaving, so north pole will be induced, and the other side we rub with north pole, so opposite pole will induce. And divided touch or double touch will make it more or stronger magnet as compared to a single touch. So this is also a way to magnetize an object. We call that as stroking. Is it clear? The second technique, method to magnetize. The first one is by placing inside a wire which is carrying a direct current or current in one way. And the second is known as stroking, like rubbing with a permanent magnet. Any doubt till this point? So only two methods are there by which you can make a magnet. One is by we are not passing a current through a material. We are passing a current through a wire, a solenoid, a circular wire, or a coiled wire, and we place the object inside. And second one is by stroking, continuously rubbing the magnetic material by a permanent magnet. How to demagnetize? How we can demagnetize? If you want to remove the magnetic field, so there is also an electrical method by passing alternating current. What does it mean? Look, now demagnetizing means the material is magnet and we want to remove its magnetic properties. So if we want to remove its magnetic properties, we want to disturb the arrangement of the domains. We don't want these domains to remain aligned. When they are aligned, this material is acting like a magnet. But we want to remove its magnetic property. So what we can do, we can connect this, we wrap the wire around, but this time we are using alternating current. What is the meaning of alternating current? the current which changes the direction continuously. So the current which is changing the direction continuously, that is called alternating current. So what happened? Like example, the first, when we pass the current, we connect a battery. So current was moving in this manner. The blue lines are representing the direction of the current. Then what happened? The direction of the current will change. The second figure I will draw here. The same material, the material does not change. Only thing what happened is the direction of the current changes. Because as the direction of the current changes, the direction of the magnetic field will also change. Now alternating current means the current continuously changes. So first it was passing, like example, from A to B. Now the current is passing from B to this one. The current is passing from B to A, and the first one it is passing from A to B. So as a result, what happened? The red lines are representing, example, the domains inside. So these are the domains inside. But what happened as a result, because the direction of the current is continuously changing, and that cause that affect the domains, because the current produces a magnetic field. So first example, domains are like this. When the direction of current changes, the domains change, vibrate, because continuously the direction of the current is changing. As the direction of the current is changing, what it caused the domains to vibrate. So as these domains are vibrating, as a result, what happened, their arrangement will be like all the domains which are vibrating continuously due to change in current. So their domains arrangement will be disturbed. As the arrangement of the domains will be disturbed, what will happen to the material? This material will be demagnetized, or it won't behave like a magnet. But normally what we do, we remove the material out from the magnetic field. So we gradually take this material out from the magnetic field, so it will be demagnetized completely. So by passing an alternating current, a current which is changing direction many times, that causes the domains to vibrate. As a result, when the domains vibrate, it disturbs the arrangement of the domain. And when the disturbance is there in the arrangement of a domain, the material will not behave like a magnet, or we can say the material is demagnetized. Is it clear? The first method, a technique to demagnetize a material. So this is one way of demagnetizing a material. The second is, basically, if you disturb the arrangement, the material will not behave like a magnet. And we should always place in a east-west direction, because otherwise earth magnetic field is there that can also magnetize the material. So whenever you are demagnetizing, you should always place in a east-west direction. The second method is by heating or a burn using a burner. Like example, what happened, the domains are arranged or aligned. So when we heat, what is the effect of the heat? Whenever you supply heat energy to a material, what is the effect? Heat causes the vibration to increase. As the vibration increase, again what happened, like the domains, due to the high temperature, the domains start to vibrate. As the domains start to vibrate, this vibration causes the domains to be random. And as they become random, it means the material will be demagnetized. But whenever we are demagnetizing a material, we should always place the material in east and west direction. Why not north and south? The earth, this is east, west, north, south according to earth. Why not north and south direction or for earth? Because if you place according to the earth magnetic field, it might be aligned again, or it might be, domains might align again. So whenever you place you want to demagnetize a material, you should always place the material in east west direction, so it won't be magnetized by the earth magnetic field. So by heating it, increasing a temperature cause the domains to vibrate, which disturb the arrangement. And another one is by hammering. We can also hammer like a material in which the domains are arranged or aligned. You strike that material by the hammer. So when you hammer something, means you disturb the alignment, you disturb the arrangement. As a result of this hammering, what it caused the domains to be random, and when the domains become random, it means the material will be demagnetized. Is it clear, the technique of demagnetizing by hammering? So if we want to magnetize, we want to arrange the domain. If we want to demagnetize, we have to disturb the alignment of the domains. So this was about the material as temporary magnet, like properties of the temporary magnet and permanent magnet. Soft magnetic materials are also called temporary magnet. Steel is a hard magnetic material. What is the definition? Temporary magnets or soft magnetic material, they are easy to magnetize and they lose their magnetic property quickly. But hard magnetic material, they are difficult to magnetize, but they remain magnetized for a longer period of a time. Temporary magnets are used in electromagnets, and whereas hard magnetic material are used to make, or steel is used to make, a permanent magnet. And these are some uses. You don't have to learn in detail all kind. These are some uses of the permanent and temporary magnet. So this table is just for information. So the topic, the simple phenomena of the magnetism 4.1, we conclude. So we started with the concept of origin of the magnetic field, magnetic poles, like poles, repel, unlike attract. Then the region around the magnet is known as a magnetic field. And we can magnetize or demagnetize a material by using different techniques. So next session we'll do the topic-wise question related to the simple phenomena of magnetism. Any doubt related to the class today?